Hello students, today in this video we'll study the topic of error function. First we'll see what is error function and what is its definition. Error function, it is defined as error function of x. It's denoted like this, ERF into bracket x, that is error function of x. It is equal to 2 upon root pi integral 0 to x e raised to minus u square du. I'll repeat, error function of x is equal to 2 upon root pi integral 0 to x e raised to minus u square du. This is the standard definition of error function of x. Now we'll see what is complementary error function. Now complementary error function it's denoted like this, ERFC of x, that is complementary error function of x. It is equal to 2 by root pi integral x to infinity e raised to minus u square du. Now see the limits. For error function the limits are from 0 to x, and for complementary error function the limits are from x to infinity. So the complementary error function of x is 2 upon root pi integral x to infinity e raised to minus u square du. Now we'll see yet another definition of error function. Error function of x, the standard definition is 2 by root pi integral 0 to x e raised to minus u square du. We'll substitute u square as t. So 2u du, it is equal to dt. Or what is du? It will be dt upon this 2u, that is dt upon 2 root t. Because since t is u square, u will be root t. So du is dt upon 2 root t. And now we'll see the limits. For u the limits were 0 and x. Now for t, when u is 0, t will be 0, and when u will be x, t will be x square. So now the limits are 0 to x square. So what we have is error function of x, it is equal to 2 upon root pi integral 0 to x square e raised to minus t into dt upon 2 root t. This can be simplified as this 2 and this 2 will get cancelled. What we have is 1 upon root pi integral 0 to x square e raised to minus t, and this root t when taken in the numerator it will be t raised to minus 1 by 2 dt. So error function of x is equal to 1 upon root pi integral 0 to x square e raised to minus t into t raised to minus 1 by 2 dt. This is another definition of error function of x. Now we'll see some of the properties of error function. Now the first property, error function of infinity. What it will be? It is equal to 2 upon root pi integral 0 to infinity, because error function of x, what we have is 2 upon root pi integral 0 to x. So error function of infinity, it is 2 upon root pi integral 0 to infinity e raised to minus u square du. Now we'll substitute u square is equal to y. 2u du is dy, and so du is dy upon 2 root y. So this integral it will be 2 upon root pi integral 0 to infinity e raised to, for u square we are substituting y, so it is e raised to minus y, and du is dy upon 2 root y, so it is dy upon 2 root y. On simplification it will be one upon root pi integral 0 to infinity e raised to minus y, y raised to minus 1 by 2 dy. And now we know gamma n plus 1. It is what? It is integral 0 to infinity e raised to minus x x raised to n dx. This is the standard definition of gamma function, and using this we can write for this integral as 1 upon root pi. What we have here, it is e raised to minus y raised to minus 1 by 2. If it's x raised to n, we have gamma n plus 1. Now n here is minus 1 by 2. So we'll have gamma of minus 1 by 2 plus 1, that is 1 by 2. So we have 1 upon root pi into gamma 1 by 2. It is equal to 1 upon root pi into, we know the value of gamma 1 by 2 is root pi. So it is equal to 1. So the value of error function of infinity is equal to 1. Now next, error function of 0. What it will be? 2 upon root pi integral 0 to 0 e raised to minus u square du. Now since the limits are from 0 to 0, the value of this integral will be 0. So the value of error function of 0 is equal to 0. Now next property. Error function of x plus complementary error function of x. We have to find the value of this. That is sum of error function of x and complementary error function of x. Now error function of x is what? It's 2 upon root pi integral 0 to x e raised to minus u square du, plus complementary error function is 2 upon root pi integral x to infinity e raised to minus u square du. This can be written as 2 upon root pi bracket integral 0 to x e raised to minus u square du plus integral x to infinity e raised to minus u square du. Now you can see here only the limits are different. You can add these two integrals and write it as 2 upon root pi integral. Here we have 0 to x and here we have x to infinity, and this term is same for both the integrals. So what we have is integral 0 to infinity e raised to minus u square du. But what is this 2 upon root pi integral 0 to infinity e raised to minus u square du? It is nothing but error function of infinity. This is the definition of error function of infinity. So this is equal to error function of infinity, and we know that the value of error function of infinity is 1. And so what we can say is error function of x plus complementary error function of x, sum of this, it is equal to 1. One more property. We have to show error function is an odd function. Now error function of x is equal to 2 upon root pi integral 0 to x e raised to minus u square du. We'll replace x by minus x. Okay. So error function of minus x is equal to 2 upon root pi integral 0 to minus x e raised to minus u square du. Now here we'll put u is equal to minus y. So du will be minus dy. Now for the limits for u are 0 to minus x. Now for y, when u is 0, y will be 0. And when u is minus x, y will be x. So error function of minus x is equal to this 2 upon root pi integral 0 to x e raised to minus u square, that is minus y square. We are substituting u as minus y. So u square is minus y whole square, that is y square, and we have this minus sign. And du is how much? It is minus dy. So we are writing dy, we are taking the minus sign outside. So this is equal to what? Minus 2 upon root pi integral 0 to x e raised to minus y square dy. This is nothing but what? Error function of x. That means error function of minus x is equal to minus of error function of x. And we know the standard definition of an odd function. If we substitute x is equal to minus x in the function, and if the value of the function it is equal to minus of f of x, that is the original function, we say that the given function is an odd function. And here we have error function of minus x is equal to minus of error function of x. Thus error function of x, it is an odd function. Now we'll see alternate definition for complementary error function. Okay, we have seen an alternate definition for the error function. Now we'll see alternate definition for complementary error function. Now error function of infinity, it is equal to 1. We have seen this. What is error function of infinity? It is 1 upon root pi integral 0 to infinity e raised to minus t into t raised to minus 1 by 2 dt. We have seen this standard definition of error function of infinity, and that is equal to 1. Now this can be written as 1 upon root pi bracket integral 0 to x square. We will split this integral into 2. It's integral 0 to x square e raised to minus t raised to minus 1 by 2 dt plus integral x square to infinity e raised to minus t raised to minus 1 by 2 dt. And we know this is equal to 1. Now this can be further split as 1 upon root pi integral 0 to x square e raised to minus t raised to minus 1 by 2 dt plus 1 upon root pi into integral x square to infinity e raised to minus t raised to minus 1 by 2 dt, and this is equal to 1. But the first integral, this, what it represents? It represents the error function x. This is the alternate definition for the error function x, which we have already seen. So this represents error function x, and plus this integral, this term is equal to 1. And we know that error function of x plus the complementary error function of x, the sum is equal to 1. So this term, it represents the complementary error function of x, and hence we can say error function, which is complementary error function of x, is equal to 1 upon root pi integral x square to infinity e raised to minus t raised to minus 1 by 2 dt. Thank you.